Nice. Alright. What's up, guys? Welcome back for another round of Linux web development. So today, we're going to be covering sets. What's a set, you ask? Well, a set is a sort of an array and an object hybrid. It uses the squiggly braces, but it doesn't have a key value pair. So, what's unique about a set is that it actually only has one unique value. In other words, you can't have 2 comma 2 in a set. It'll erase the second set because it's not unique. There is an exception to this, and I want to show you guys, so let's go. Alright, I already have VS Code open, guys, and I'm gonna clear that. Alright, so make a new file. We're gonna call it sets. You know what? Yeah, sets testing.js. There we go. Alright, so I'm gonna paste in the set because I want to show you guys that it gets rid of duplicates. Boom. Okay, so you can see how there's multiple 4s, a couple 2s in there, some 3s, 4, so on and so forth, right? So we're just gonna go ahead and console log my set for now. Okay, console.log. As usual, let's run it with node mon, and it's testing. Wait, what? Hold on. Let me fix that. Hold on. Let's fix that, guys. So we're not testing. We're testing. Set testing. Yeah, that works. Okay. Set testing JS. Boom. There it is. Okay. So you can see how there's only 8 values in this set, and all of the doubles got erased. So there's only unique values. I was actually playing with this the other day, and I happened to notice if you have an actual key value pair in there, say we got name equals 2, and I know, but like name can't equal 2, but let's just say for the sake of argument it's an integer. So look, it has it twice, and the problem with that is that those are unique values, but they're not being deleted. The double isn't to be deleted. Why is that? So, if you know anything about an array, a primitive array anyways, they get stored in memory, kind of like a table, right? You got this nice table, right? And we'll just say this is kind of like your computer's memory system, right? And each grid is like a place where it can store data. And in each grid, you have some kind of reference towards some kind of memory. So let's say that our array lives here. Well, if that array needs more space, it has to make more memory. So the computer has to clear this block out so that it can expand into here. So you'll have more memory for that array. But this set is a little different. It's kind of like a linked list, and we'll get into that, but all you need to know is that a linked list has a series of data, sort of like an array, but each piece of data, instead of being stored encapsulated in an array, it actually doesn't have those. It has pointers that points to another reference in memory, like so. So this one could live here, and this one could live here, and this one could live all the way over here somewhere, right? And each one, this one's like, hey, it's over here. And then this one's like, hey, the next one's over here. And that's just how that works. It doesn't have to be all blocked like this. So I think the reason that this is happening right here is simply because we have okay, so I think the reason this is happening is because we have these 2 objects, and I think each object actually has its own unique place in memory. So it's got its own unique ID. So instead of having 2 and 2, which is the same value and computer memory reference, I think each object has its own unique reference. So I think this object could live somewhere over here, and this object could live somewhere over here. I think that's why it doesn't get rid of those doubles like it should, like it does for the rest of the integers, or if you had strings in here. Let's pop some strings. Hello and hello. Right? So there's obviously two in there. And they're separated, so now you got one hello. See how that string itself is unique. There's no second hello. But the objects, however, they don't work out like they're supposed to. So I think that's because of the memory reference. Maybe I'm wrong. If I'm wrong, you know, check the comments. Maybe someone else can know. But I'm pretty sure that's why. Because these have unique values. Memory values. If that's confusing, don't worry about it. We'll get into linked lists, but not right now. So, anyhow, back to sets. Sets. Let's get rid of these confusing objects. And we got console log my set. So, what can we do with this set, guys? Find out. So, sets. Sets cannot. Oh, sets are immutable. In other words, you can't say my set index 1 equals some val. You can't do that. It's immutable. It won't let you change it. That's all you need to know. In an array, you could modify the data, but in a set, you cannot modify. It's considered to be immutable. Sets are a great tool because you can take a set, or let's say you have an array, just like, oh, look at that. So what they're doing here is they're constructing a new set from an array, and they're basically making all these values unique, as you can see here. Can you see here? Okay, so as you can see here, but if you didn't want to return a set, you could wrap that in its own array, right? Wrap it like that, and then put a spread operator, and you'll actually have an array of unique values instead of having a set. Why would I not want a set? Turns out you actually can't index a set. And the issue with that is if you wanted to actually get the value at my set 1, 2, right, the 3, or actually it'd be this one because they're unique. You can't print this out, so I can't say console.log my set at position 2. It won't return it. It has an error. It has an issue right there, undefined. So we can't do that. How do we get around that? Let's build a function. So I was just playing around with this, so check it out. Let's create a function, const get in value at index, and it's going to take a set and the index. So first we're gonna want to know the count. We're gonna have an incrementer that what's gonna happen is we're gonna loop through that set, and then when the count is equal to the index, we're gonna return that value. So first we're going to get a count number, and then we're going to set a value, the return value, to some number. Right now we're gonna set their false. So the reason I'm setting it to false is if the value at index is equal to 0, 0 is actually considered to be a falsy value. So if I go to check my conditionals and I say if there's a return value, but the return value happens to be 0, it actually won't return that value. So what we're gonna do here is we're going to create a loop, and we're going to say my set dot map, and it's going to have element, and then we're going to pass it to a loop, and we're going to say count plus plus first of all, and then we're going to say if element, or yeah, no, if count is equal to index, then we're going to set return value to the element. That's it. Okay. Now, after it finishes this, we're going to return the return value. There we go. Okay. And so, what's happening here? Oh, you know what? We also need to check this, right? Like I was saying. So, if there's a return value, then we want to return the return value, right? However, if there's not a return value, we want to return some kind of error warning. So we're going to return index to high or too low. So conditionally, if there's a return value, or the return value is equal to 0, then return value. Because if it is 0, this won't pass. It'll be false and it'll return this. We don't want that. So there we go. So let's try this out. So my index dot get get value at index. We're gonna pass it my set and index 0 because we know 0 is 0. And it crashed because map is not a function. I'm using the wrong function, guys. It's not map, it's for each, capital E. Now, there we go. 0. Return 0. Now, if I give it a different index, let's get a little. So 0, 1, 2, 3, 4, 5, 6. Let's go passing 6. And that's not the correct value. It's index 5. I counted too much. There it is. Okay, so now you can see how we can build our own little function to return a specific value within a set. What's an easier way to do this without iterating through each element? Well, I mean, you could just, you know, turn it into an array, like I was saying earlier, where, oh, wrong brackets. There we go. You could just, you know, boom, there's an array. Now you can just say my set at index 2, and, you know, now I crashed. It doesn't like it. It said, I don't like that. You're right. You're right, node, as always. There you go. And there it is, you know. But now it's not a set, so if you add anything to this, it won't be unique. Well, it might be, but it's not guaranteed, right? So now, how can we add things to a set? Well, we can say my set.add, and we can add, I don't know, a value of 10, and then we want to do that. So we added 10. Let's see, what else can we do here? We can add, we can delete a value. Delete 10. Oh no, it's not there. We can delete, actually, let's delete hello. I don't want that there no more. Dang it. There we go. Alright, so hello's gone. It was there, it's gone now. What else? We can clear it, my set.clear, and assuming that, yep, empty is a whole set. That's handy. And then there's one more that's pretty important, and it's a conditional. So we're gonna say if my set.has, if hello is in the set, then hey, let's print it out. Let's print out the entire set. It doesn't like it. It says, oh, right there. Boom. Forgot that one for the if statement. Okay. And it's still crashing because of this issue, because you don't end them like that. You end them like that. And there it is. Yep, there it is. Okay. Clean exit. So because we deleted it, it's not doing it. So let's get rid of that statement. And there it is. So conditionally, it's asking, is this exist? How do I know? Let's find out. Let's go to this down here. Let's log it. Let's get rid of the if. And let's get rid of that. Nope, let's not get rid of that. Okay. So say it's returning true. And let's give it a value it doesn't have. Let's give it 100. And that does not exist. Another thing to note with has is because of those unique memory references, if you were to ask if it had an object with a value of 2, and it existed, oops, and that actually happened to exist in here, right, it's going to return false, because as you've seen before, sets do not make unique objects. So that might be worth noting. So we got add, has, delete, clear. We can iterate using the for each. We can use them to remove duplicate values from a set as long as those values are not objects. Come back over here. Alright, so you can see how sets can be pretty handy. They help you remove doubles from an array, or if you have a set already existing, then you can add, and if that value already exists within that set, then it will actually not add it. It'll try to add it, but when the has fails, it won't add it. So just keep an eye out for those objects and you'll have a good time with sets. They're not so bad. They're a little weird because you can't index them like normal, but you know, turn it into an array and then just get the index that way. But alright guys, so the next one I'm thinking about covering looks like loops, and there's a lot of loops we covered. If you think about it, we covered, you know, map, for each, we didn't do for in or for of, but I think we checked out one of those. I think it was for of, I can't remember, but it's the one for objects. And then there's the for loop itself, just a dry regular I++ for loop, and we'll go back over those ones in the next one. It'll be fun. So I'll see you there. Peace.